Hello, my students in grade 8. This is lecture 12 in mathematics, and the title of our lesson is Pythagoras Theorem. What are the objectives of our lesson? Number one, as a reminder, I will remind you again of two theorems we studied this year. Number one, the median segment theorem, which we apply in a right triangle. Number two, the midpoint theorem. Then we will identify and apply the Pythagorean theorem in a right triangle. We will identify the converse of the Pythagorean theorem. We all know that each theorem has a converse. And then we will talk about special right triangles. Let's refresh our memories and remember two important theorems. Number one, the median segment theorem. Where do we apply this theorem? This theorem is only applied in a right triangle. What does it say? In a right triangle, the length of the median issued to the hypotenuse from the vertex is equal to half the length of the hypotenuse. For example, if I have triangle ABC right at A, M is the midpoint of BC, then MB is equal to MC. AM is the median issued from A to the hypotenuse BC. Then, according to the median segment theorem, we say, since M is the midpoint of BC and AM is the median issued to BC, then using the median segment theorem, AM is equal to BC over 2. Then AM is equal to MB is equal to MC. Now, the theorem number 2, the midpoint theorem, applied in all kinds of triangles. What does it say? If I have any triangle ABC, M taken the midpoint of segment AB and N is the midpoint of segment AC. Then the line joining the two midpoints, which is MN, will be parallel to the third side BC. Not only this, also MN equals BC over 2. Then this theorem says the line joining the two midpoints of any two sides in a triangle is parallel to the third side and equals its half. Why do we use this theorem, the midpoint theorem? We use it to prove two parallel lines or to find the measure of MN or BC. Now, what's a right triangle? We all know that in a right triangle, there exists a right angle. So these two sides, which I will call leg 1 and leg 2, since they have a right angle in between, then we say leg 1 is perpendicular to leg 2. Then leg 1 and leg 2 are two perpendicular lines. We all know that in a right triangle, the side opposite to the right angle, we call it the hypotenuse. So this side, which is opposite to the right angle, is called the hypotenuse. And we can see that the hypotenuse in a right triangle is the longest side. It's longer than leg 1 and leg 2. Now I will talk about Pythagoras or the Pythagorean theorem in a right triangle. It's very important to know this theorem, which is the Pythagoras theorem or the Pythagorean theorem, we cannot apply it unless our triangle is right. So identify and apply the Pythagorean theorem in a right triangle. What does this theorem say? In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the two other sides or legs. So let's look at triangle ABC. We can see that the triangle ABC is right at A. So at angle A, here we have a right angle. Who's my hypotenuse? My hypotenuse is BC. It's very important always before we start applying the Pythagorean theorem to say who's my hypotenuse. So BC is the hypotenuse. As you can see, to use the Pythagoras theorem, why do we use it? We all know that in a triangle, right or whatever, we have three sides. So I have side AB, side AC, side BC. We are given the length of AB, which is the 3 centimeter. The length of AC is 4 centimeter. We should calculate the length of side BC. So we use the Pythagorean theorem to calculate a missing side length in a right triangle. What does it say? It says the square of the length of the hypotenuse. So my hypotenuse is BC, so I write BC square because I am saying the square of the length of the hypotenuse. So BC square equal the sum of the square of the other legs. So AB square plus BS plus AC square. So BC square equal AB square plus AC square. But how do we apply it here? We say always, in which right triangle I'm applying the Pythagoras theorem? So we say triangle ABC is right at A, then we use or apply the Pythagorean theorem. BC square is equal to AB square plus AC square. I replace AB by 3, so 3 square plus AC is 4, so 4 square. 3 square is 9 plus 4 square, which is 16. 9 plus 16, then BC square equal 25. But I should find BC. To find BC, I take the square root of both sides. So radical BC square is equal to radical 25. Here the square cancels the radical, so BC equal radical 25, which is 5 square. Then BC is equal to 5 centimeter. In this way, we calculated the missing side in a right triangle. So this is how we apply the Pythagoras theorem. Every theorem has a converse. Why do we use the converse of the Pythagoras theorem? The converse of the Pythagoras theorem, we use it to prove that a triangle is right. So what I will be given to apply the converse of the Pythagoras theorem? I say in a triangle, if we could prove that the sum of the two leg square is equal to the square of the hypotenuse, then it is right. So I will be given any triangle ABC. They didn't say it is right. I'm given AB, AC, and BC. So I have the length of the three sides. I should prove that the triangle ABC is right at A. Then I should find AB square, which is 4 square, which is 16. AC square, which is a 3 square, it's 9. And BC square, which is 5 square, equal 25. So I get each side square alone. Then I add the smallest two sides. So I add AB square, which is 16, plus AC square, which is 9. 16 plus 9 is equal to 25. Then AB square plus AC square equal BC square. Using the converse of Pythagoras theorem, we say that the triangle ABC is right at A. Now I will continue. Let's talk about special right triangles. So I will talk now about two special kinds of right triangles. Number one, the semi-equilateral triangle. Which triangle we call it a semi-equilateral? It is a triangle having an angle which measures 30 degrees, an angle which measures 60 degrees, and an angle which measures 90 degrees. So as you can see in a semi-equilateral triangle, we have a right angle and the other two angles always one measures 30 degrees and the other measures 60 degrees. This triangle is very special. Why? Let's talk about triangle ABC. We can see that angle B is 90 degrees, angle A is 60 degrees, and angle C is 30 degrees. So we say that the triangle ABC is right at B. Here, since I have 30 degrees and 60 degrees, then it's not only right, we call it a semi-equilateral triangle. Now I am given the side AC, the measure of side AC is 6 centimeter. I have two missing sides which are AB and BC. I should calculate these missing sides. I cannot apply Pythagoras. Why? Because I have two missing sides. So here in the semi-equilateral triangle, there are two rules to find side BC and side AB. If I look at side BC, it is the side facing the 60 degrees, opposite to the 60 degrees. So BC, which is the side opposite to 60 degrees, it has a rule which says BC, the side facing 60 degrees equal hypotenuse radical 3 over 2. We should memorize this rule. So the side facing 60 degrees in a semi-equilateral triangle equal hypotenuse radical 3 over 2. Then I write BC equal, who's my hypotenuse? It's AC. So AC radical 3 over 2, I'm given the length of AC 6 centimeter. So 6 radical 3 over 2, I divide 6 and 2 by 2. Then BC is equal to 3 radical 3 centimeter. I should find the length of side AB. AB is the side facing the 30 degrees. Also, there is a rule. AB, which is the side facing 30 degrees, equal hypotenuse over 2. Then AB equal AC over 2. 6 over 2 is equal to 3 centimeter. Please memorize these two rules. These are very important. We always apply them in a semi-equilateral triangle. The next right triangle, which is special, we call it the right isosceles triangle. What does a right isosceles triangle have? It is right since it has one right angle, and it's isosceles because it has two equal sides and two equal angles. Each angle, base angle in a right isosceles triangle, measures 45 degrees. So here I have a rule to find the length of BC directly. BC, because it is the hypotenuse in a right isosceles triangle, we say BC is equal to A radical 2. Whose A? It is the side AC or side AB. Then let's apply it. Let's apply this rule. So given triangle MNP, which is right isosceles at M, we are given side MN equal 5 centimeter. We should calculate NP. So we say since triangle MNP is right isosceles at M, so angle NMP equal 90 degrees, MN equal MP equal 5 centimeter since the special vertex is M. So the hypotenuse NP is equal to A radical 2, which is side radical 2. The side is 5, so NP equal 5 radical 2 centimeter. Let's apply exercises about the Pythagoras and the converse of Pythagoras. Given triangle ABC right at A, we are given AB equals 6 centimeter, AC 8 centimeter. We should calculate BC. We say since triangle ABC is right at A, apply or use the Pythagoras theorem. Who's my hypotenuse? It's BC. So BC square equal AB square plus AC square. Then I replace AB by 6 and AC by 8. 6 square is 36 and 8 square is 64. So BC square equal 100. So I make the square root of both sides to get BC. So BC equal radical 100, which is 10 centimeter. Another exercise, I have a right triangle given the length of two sides, and there is a missing side, which is EG. So to find this missing side, we also apply the Pythagoras theorem. We say in triangle EFG right at E, who's my hypotenuse? So we apply Pythagoras. The hypotenuse is FG. So FG square equal EF square plus EG square. Now, EG is the missing. So EG square equal FG square minus EF square. Then I get EG equal 4 centimeter. Please apply these exercises to practice more on a draft. Let's apply an exercise about using the converse of Pythagoras. So we are given triangle ABC. We have the length of the three sides. We should prove that the triangle ABC is right at A. So I apply the converse of Pythagoras. I get each side the square alone. AB square, which is 6 square, which is equal to 36. AC square, 8 square equal to 64. And BC square, which is 10 square equal to 100. I keep the 100, which is the longest aside, and I add the two small sides. So AB square plus AC square equal 36 plus 64 equal 100. Then it's equal to BC square. Using the converse of Pythagoras theorem, triangle ABC is right at A. Also in this lesson, I want to remind you about the circle we studied before. We know that in a circle, in each circle, we have this line, which we draw in a circle. We call it the circumference, which is the line of the circle. We draw it using a compass. And after drawing the circle, when we put our compass, we call it the center of the circle. In a circle, we have always two special lines, which are the radius. We can draw infinite radii in the circle. And the radius is a line from the center and cuts the circumference in one point. And we have another line, which is the diameter, which passes in the center and cuts the circumference in 2 points. As you can see, the radius is equal to half the diameter, or the diameter is equal to radius times 2. Always to draw a circle, we open our compass as the length of the radius to draw the circle. Also, in a circle, we have an arc. The arc is a part of the circumference of the circle between two radii. We have a line which is called the secant. The secant is a line that cuts the circumference in 2 points, but it doesn't pass in the center. The chord is the part of the secant inside the circle. So this is the secant. The part of the secant from the circumference to the circumference, we call it a chord. And we have a very special line in the circle, which is called the tangent. Always to draw a tangent, we take any point on the circle and we draw a line touching the circle at the point from outside. This is called the point of tangency. Always to calculate the circumference of the circle, we have a rule, the circumference equal 2 times pi times r. 2 is a number, pi is a constant or a fixed number in a circle, which is 3.14, and r is the radius of the circle. To calculate the area of any circle, the area equal pi radius square. Also, pi is the 3.14. Now, we have this slide, which is very, very important. I have in the first example a circle. This is a circle C, O 3 centimeter. What does this writing mean? O is the center of the circle, 3 centimeter is the measure of the radius. So to draw this circle, I open my compass 3 centimeter and I draw it. After I draw it, I directly say O is the center of the circle. AB is a diameter, so I draw AB a diameter, which is a line passing in the center of the circle. And I take a point M on C. On C means on the circumference of the circle. Here I took M in 3 different places to show you that wherever you take M, it's correct. So we can take M here up, we can take it here, or we can take it here. Now, after taking M on the circumference, and since AB is a diameter, so angle AMB is equal to 90 degrees. It is an angle facing diameter. It's called an inscribed angle facing diameter. It's always equal to 90 degrees. Then triangle AMB is right at M. Also, if we took M here, AMB angle equal 90 degrees because it's an inscribed angle facing diameter, or down, it's the same. So triangle AMB, wherever M on the circumference is, since AB is the diameter, it's equal to 90 degrees. It's an inscribed angle facing diameter. And the nature of triangle AMB will be a right triangle. Another one, if I have a right triangle EFG, we studied before in grade 6 and in grade 7 that around each triangle I can draw a circle circumscribed. What is the circle circumscribed? It's a circle passing through the 3 vertices of the triangle. It passes in E, in F, and in G. In a right triangle especially, to draw a circle circumscribed about the triangle, I need to know where is the center of this circle. Always in a right triangle, the center of the circle is the midpoint of the hypotenuse. Who's my hypotenuse? It's EG. So the center of the circle will be the midpoint of the hypotenuse EG. This is very important. Now, finally, I will tell you about an angle between the tangent and a radius. If I have a circle C of center O and I drew a radius which is OB, so B is on the circumference. At B is called a point on the circumference. I draw a line D which is tangent to the circle at B. So B is the point of tangency. Point M, I took it on the tangent as any point. Then after drawing the tangent at B, we can see that angle MBO, which is the angle between the tangent and the radius, angle MBO here or MBO here, I will annotate it on the figure. So angle MBO, this angle is always equal to 90 degrees. Why? Since it is an angle between the tangent and a radius. So if I joined OMB, I can see that the triangle OMB is right at B. And let me erase. Okay. And I will continue now. So as you can see, this lesson is very important in math. There are many rules, little rules. Please watch the video well. And if you have any question, just contact me. Thank you for listening.